The aim of this project was to investigate the effect that prolonged periods of cold ischemia time occurring during cold preservation of kidneys before transplant has on the quality of these kidneys. We assessed this using a novel preservation technique called normothermic machine perfusion, NMP. It preserves kidneys with warmed oxygenated blood at 37 degrees. Using this machine, we can measure in real time the kidney function and also come up with an assessment score that determines kidney quality before transplant. What we did was we collected 10 kidneys, porcine kidneys. 5 kidneys underwent cold preservation for 4 hours. This is the short cold ischemic kidney group, while another 5 underwent cold preservation for 24 hours. This is the long cold ischemic kidney group. Once on the machine, they were perfused with the red blood cell solution at 37 degrees. During the perfusion, we measured for markers of kidney function, such as renal blood flow, resistance in the renal arteries, and urine output. We also measured for injury markers, such as aspartate aminotransferase and lactate dehydrogenase, using blood gas analysis. We took the kidneys off the machine when we felt they have deteriorated beyond repair, such as when their flow was less than 50 mL per min per 100 grams and the global appearance of the kidney was patchy or purple. Once the kidneys came off the machine, we graded them based on their macroscopic appearance, shown here, total mean renal blood flow, and total urine output. A score of 1 means highest quality for transplant, while a score of 5 means lowest quality. What we found was that during NMP, the short cold ischemic kidneys, shown in blue, had higher mean renal blood flow throughout perfusion, while the long cold ischemic kidneys had lower renal blood flow, suggesting that the short cold ischemic kidneys were functioning better on the machine. We measured resistance in the arteries and found that the long cold ischemic kidneys had higher resistance throughout perfusion compared to short cold ischemic kidneys. We found that total urine output was high in the long cold ischemic kidneys, although this could be due to an outlier. We found that the cellular injury marker, aspartate aminotransferase, was significantly high in the long cold ischemic kidneys and was increasing throughout the perfusion, suggesting long cold ischemic kidneys had higher levels of injury. For LDH and lactate, we did not find any significant differences between the two groups. For the assessment score, we found that all 10 kidneys scored between 1 to 3. And from previous experiments, these mean that they are viable for transplant. However, there was no significant difference between the two groups. In conclusion, even though the data shows that the short cold ischemic kidneys had higher renal function based on their low resistance and high renal blood flow, there was not enough consistent data to say that prolonged periods of cold ischemia negatively impacts on the quality of the kidneys. In the future, we would like to include more kidneys in our study and also optimize the NMP protocol.